So, welcome. Thank you very much for joining us. First of all, I'm still impressed that the class is so numerous. That's brilliant. Could you guys help me and switch on the monitors there so you see what we're actually doing? For today, a few things. Some of you, well, in any case, at least one of you has noticed that the review system was open and got crazy. I'm not sure who it was, but crazy is the keyword here. So it's good. So, and the person actually went all in, and actually, or perhaps two people actually went in and also kind of realized they can do as many reviews as they want. So kudos. So really brilliant. So that's good. There were many inquiries with respect to, okay, how does this thing work? We didn't do code review. And last week I put a survey out and just to assess how you guys stand in terms of experience in code review. And that's really helpful. So I appreciate everyone who participated. So 35 responses, cool, that's good. It's about, I would say 40% of the course, so roughly, I guess. So that's pretty good in terms of response rate. But what we see there is that people mostly either have no experience or they have some sort of experience by, having heard about it, saw it, someone doing or talking about it, or perhaps some talks on YouTube or the like and so on. And there are some people that have some experience and very few that have a good experience with it. So part of the degree or the objective of the degree is, of course, to make you proficient in terms of code review. So, and as part of the survey, you were able to respond to what you think code review needs to, or what good code review needs to include. So, but instead of just digging into it, I'm just wondering, just from the class perspective, I will not ask you who, of course, did the survey here, right? So, but instead, I would rather like us as a class to recollect what you think should be in a good code review, which you are going to do as part of the reviewing exercise. But we go into that in a second later. But what do you think is important for a good code review, or code review in general? See if we trigger them out, then we can match them against the responses in the survey. No one has any opinion? No code reviews? Right, do you want to forego this task? No, certainly not. Please.
You'll have to know what the code is supposed to do, so you need some sort of requirements.
Very nice, very nice. Yeah, that's very good. So you have both variants. So in this case, yes, we're doing, we're assessing in how far is code is developed to spec, right? But you can also do, so that's good, that's correct, and that's what we're doing here. But there's also different forms of code review. It's just about code quality, right? So where the actual function, the activity is secondary to other aspects, which we probably unravel in a second. But there's a good point. So the commitment to spec, right? So this will be important for assignment 1 and 2, of course. Any other viewpoints on code reviews? How do I trigger the more knowledgeable people here? Because they are here, but they're very shy today. I don't know why. Usually a bit more outspoken. Please, all in. Else ask those guys, and that's getting boring.
There's one.
There's one.
The complexity of the code. You
Yeah.
can do something. The functionality can still be there, but you can write 10 pages of code when you only needed 5 lines.
Okay, that's an interesting discussion point. Yeah. So complexity of code. Is complexity always good?
No.
So what is the trade-off? The complexity is in relationship to something else. So it's not like you're optimizing for complexity and then you'll be fine, right? You need to keep something else in mind when thinking about complexity.
Readability?
Readability, exactly. And what else, perhaps? Readability is actually the right term, but
how easy it is to understand the code.
Yes.
Or what he's trying to do.
That's right. And how do you ensure that someone else knows what it's trying to do? Documentation, but also in terms of the documentation is a good point. That's right. But it also depends on the kind of specificity of your area or domain, right? So you need to have code that's reviewable by the right audience, right? If you have people that are working with you in a team, right, and they're highly specialized and they understand your algorithms and the complexity you're usually applying, then it's a lot easier for them to comprehend as opposed to, let's say, an open environment of general purpose developers that would probably be challenged if you have a very specific, highly complex code piece in there, right? So it's also important to keep in mind whom are we aiming at, right? So, but complexity is a tricky one. So that's the kind of a wicked problem. You don't want to keep it too simple, but fundamentally the idea, especially in Golang, is to optimize for simplicity because that's one of the design principles of the language. There was someone there?
Yeah, I was just going to say readability.
Readability?
Yeah.
Sorry for taking that away from you. But yeah, readability, exactly. And Go is really good at this, right? I mean, it's not particularly convoluted. It's a lot simpler than the programming languages you have learned so far. At least I hope so. Don't know.
What's one of the things Golang tries to do that other languages like C and C++ don't care about at all? What annoys you when you're compiling for Go?
It tries to remove all the unnecessary shit.
Yeah,
Well,
yeah,
that is
exactly.
highly abstract, yeah.
And it tries to enforce standards on you. So you're not allowed to have your parentheses where you want them, because or may want them, because it's a compiling error to have the parentheses in the wrong place and not to use a variable. Not because it's necessarily less readable, but they want to enforce the standard so that all Golang code looks the same. Because then it's easier to go from one project and have learned Golang than going to another Golang project and already like feeling that that's similar. So it's easier to read new code from other people.
Yeah. All right. There was a comment here. Yeah. Similar? Okay, good. Yeah. So there's so what Jonas is alluding to is there are more general features in terms of code review, but also language specific aspects, right? So that we need to regard. And Go is pretty good at this. That's right.
I forgot the word, but it's how difficult the code is to break, or the program is to break.
Oy. What is the word, guys?
Rigidity.
Reliability, robustness.
Yeah, robustness potentially. If you just have one, for example, this project, if you just do the specifications,
Yeah.
then it doesn't break. That's fine. But it's like one variable or no testing, no input validation, etc. It's good to have.
Yeah.
It falls apart very fast if you have no checks.
Yeah. Okay, that's a good point. Yes. So you're alluding to testing as being an important part of code as well, right?
If you give it to a random and then just instantly breaks it, it's kind of.
Yeah, that would be yeah, that's true. Especially in dynamically typed settings, that can be tricky, right? So if you have type enforcement at compile time, it's not. That's safer a bit, but then you still have the input validation problem. Yeah. Okay. Any other comments? What else? Anything else we need to bear in mind?
Any redundant coding there, because it becomes really
Yeah.
easy to determine what's necessary and what is just not been removed.
So that's cool. So we're getting into the nitty-gritty, into the weeds. So no redundant code, right? So, okay, where would you expect to find redundant code, or where shouldn't you, but probably will expect to find redundant code?
Well, comment out code.
Well, I think that's a different story, right? So redundant code is bad. Commented out code is probably worse. Why is commented out code slightly worse, or actually a lot worse, probably?
It could potentially get uncommented at some point.
Exactly, right? So number one, it could be uncommented for whatever reason, and especially if it's undocumented, no one knows why, because it probably shouldn't be there. Secondly, uncommented code is susceptible to code rot necessarily, right? Because your code moves on, you change it, you may use the convenience tools of the IDE to automate things, refactoring, things like that, right? And this will never consider commented code. So suddenly your code is totally legacy, but why is it still there? It's more probably sponsoring more confusion than help. If you have redundant code, at least you can identify it and then think about doing something with it, right? But it's still running code at least, or used code, so it has value and has meaning. It's meaningful to look at it in the first place. So commented code can be slightly worse. So yeah, please, there's some comment.
Are we doing any type of static code analysis?
Right. So no. So well, you do actually do static code analysis in the sense that you are doing a code review, right? By actually using a code, but you're not using tools for that, or at least we don't expect you to. If you want to go in, you know. So okay. So we had general features of having clean code to some extent, avoid redundancy. Coding to a specification was mentioned here in particular. We want to avoid commented code most likely. Think about the continuum of having readable code on the other hand, but in the other hand having sufficient complexity. So my point there was mostly that it really depends a bit on the audience, right? If it's a highly specialized audience, I think you can get away with a lot more complex code. If it's not the case, then you probably want to consider other aspects. What are general best practices that we get there in a second. Okay. All right, I'll just run you through what some of you responded. I vetted it beforehand, so there's no personal information there, so it will be fairly safe to go through this. But I think you have really good points, and they operate in various levels of abstraction. Some of them very concrete, very specific. Some of them very high level, which is both brilliant, because one is more general when you think about code review, and the other one is more specific to what we are going to do here, right? So there was a reference to code efficiency. That's, I think, what Benjamin is pointing out. I think when you mean complexity, no?
Yeah.
Right, so to some extent, but it's also coding efficiency in a sense. How can you express something that would take 10 lines perhaps in 3 lines or something, right? So, but it really depends on language. Go is generally not a hyper, Go coders are generally not friends of that idea necessarily. Variable naming is important, so we don't just name variables x, y, and z, unless, of course, they represent x, y, and z in a 3-dimensional space, so then that's probably okay. But in all other cases, you probably want to have reasonably meaningful variables that make sense. Of course, variable naming depends on the scope, right? So if you have a variable that is globally accessible, well, you need to be slightly more descriptive. If a variable is a count within a loop, well, the scope is too small to actually bother with proper naming. So so readability is an important point. Code duplication, all the aspects we heard about it. This is really nice, typography. Humans have narrower attention span when reading and should keep lines short and clearly divide semantic blocks like argument lists, function bodies, and with white space. So that's really nice. So that's really about how to write code or write functions particular, I guess, and use visual blocks actually to separate different code aspects. I think you guys do this intuitively already. You kind of have learned this in one of the C courses, I guess, in the first year. At least that was my impression. So yeah, use white space because that's pretty much free. It helps you to clearly open up and divide the perspective. There's also an argument for keeping the lines short, right? There's always the debate, hey, why do we need to optimize against 80 characters per line, right? There's historical reasons, but there's also very pragmatic reasons that it's simply more legible because you can keep it in focus. So you don't need to have an extended attention span. So readability, again, structure, simplicity, sounds good. I think I would sign those 3 ones because that's generally what you're looking for. Here's something that writes less about the code, but actually more about the reviewer. The reviewer, himself or herself, must have a general understanding of coding in the first place. Hooray, yes, I guess, that's very good. And the reviewer should have a good understanding of what the code should do, right? So you need to get an understanding how narrow or wide in scope, but you need to understand what at least the function is going to do before you actually look at it and analyze it, because you may misread some clever tricks that the developer does as inefficient or the like. Reviewer should have good understanding of the language, of course, that's granted, and should have a good understanding of the demands that the assignment makes to be able to tell if the code is a complete failure. Decent or very good. Again, you need to know the specs, right? So if you know the specs, then you can test against. That's very important in this context. The advantage is all of you know the specs, right? So that's brilliant. So if you review each other's code, you will be the best possible reviewers for this purpose because you tick those boxes. First of all, knowing the language to a comparable extent in any case. And certainly know what the assignment was about. So here's some concrete demands. Sure, give us concrete guidelines to follow and what should be doing the assignments. Sure, how assignments will be graded by teachers should be known in advance. Yep, you'll see that in a second. What else? Promote clean code, that's a good one. There was something else I was really keen on. So documentation and comments. What's the position on comments? Do people do commenting?
Yeah.
Yes? By force or by necessity? We always have this dream, and the dream is as follows. We have you write Go code in assignment 1, right? And 1 year later, we give you the same Go code again and have you understand it or explain it to us, right? And that's when the commenting makes all the difference, because you suddenly realize, oh heck, what the heck what's actually happening here? What is this handler doing? Why am I having this command and so on, right? So it doesn't pay off right now, but it would pay off in the future. So in any case, if you write something that's not only targeted, that is targeted at you and to your future self, or at others, it's probably very wise to think about commenting, right? If you had your own script and you do something, your pet project and so on, and it's only you looking at the code however repeatedly and so on, fine, whatever. But as soon as you think about a wider audience, and here in this case you needed to assume that we have a wider audience because we told you it would be peer review, meaning you wouldn't know who would look at it. That's the idea. You kind of want to think about commenting as important aspect. Yeah, pointing out bad practices. So if you know them, for example, Jona pointed out some in the context of Golang, point them out, or identify code that is prone to causing any issues in the future. One thing that code reviews also look at, I mean, as a kind of a non-functional characteristics, is style, right? So in many languages there are different style specifications. For example, if you develop in Java, there is the Oracle specification of how you lay out code and so on. And then there's the Google specification and so on. And it doesn't really matter which one you commit to as long as you're consistent, right? You don't switch your convention in the midst of your implementation. So that's the key point here. As you mentioned, in Go, there's next to no flexibility on that one, because GoFimt will require you to format it according to the Golang guidelines, which is really helpful because it means Golang code is generally readable at least, and syntactically what you expect in terms of style. So that's a good comment there that someone made. So I really appreciate it. Yeah. This is a good point. So apart from all the obvious ones, of course, looking at code, reviewing code, and helping you guys, understand errors and so on, pointing out inconsistencies in behavior and so on. One thing is about how you approach this, right? What's your attitude with it, right? So it's very easy to be a bit of a hater and looking at someone's code and say, "Oh, that's all crap, screw you, and why did you do this? You're useless," and that. That's a risk anytime you're subjected to assessing someone else's work, right? So, but part of the professionalism is it to step back from that. That's why we do it anonymously as well, so it can be also backfire, but okay. But in any case, that's where you should want to be able to step back and look at code objectively as far as possible. That's the case, based on your experience and based on the instructions you may actually get, and look at the code and highlight shortcomings in the code. Be constructive of what can be done better. Don't just say this, block of code sucks, but actually say what should have been done better, at least by example or something like this, and not make it personal at all, right? So it's really about the code. It's not about you as a reviewer, and it's not about the coder either. It's really about the code quality, because that's what's ending up in some product. Whether your name is attached to it or not is a secondary issue. It will end up in some running product, and then it's when code quality actually counts, and then it should actually hold up to certain standards. And that's why it's important that you do your work thoroughly, but it's also important to respect each others as professionals. Everyone makes mistakes, me more than others, but I think it's worthwhile to bear in mind that it can happen to you as well, especially if you're in a learning phase yourself, right? If you're in a company, you'll be a junior at some stage, even though you're more confident perhaps right now. And then it may well be you who receives instructions or critical feedback on your coding. So that's the point I'm making here. Don't be constructive, right? So point out weaknesses, go all in, right? But be clear it's objectively about the code, and perhaps provide constructive feedback if you can, or at least pointers as to how it could be improved. That's very important. So that's a very good comment. So thanks for putting this in. One of the aspects, learning is a good one. So give the reviewer an opportunity to learn. Right? Point them to resources if you see, or give concrete ideas of what people can do better.
Just one
yes,
comment,
comment please.
Ego thing, it works both ways. So it works for the one who gets the comments and for the one who is giving the comments. So sometimes you say, that's the best way of doing something, but it may not be. Maybe the way somebody implemented something is actually better. So you have to watch it objectively from both roles. So as Chris was saying.
Cool.
So try to learn through the experience. So try to learn how certain things can be achieved from those who you're reviewing, but also from the comments you're getting from the reviewer as well. Yeah.
I mean, that's true for the whole bachelor, right? So they fundamentally need to learn not to be defensive, but to take constructive criticism. That's the fundamental idea. It will come back to you in any case throughout your degree, independent of coding. That's a good point Marius is making. Looking for errors, code length, clean code. Code length, What's the issue with code length thing, right? What do we need to think about there? Code length, how do we deal with this?
Avoiding repetition.
Repetition, that's good. What is another aspect that relates to code length? How can we reduce it?
in separate files.
Very good, right? So how do you, what's the term for that, doing that and putting into separate files? I like it, it's very descriptive.
Modularize or
That's correct, right? So you modularize your code, right? So how do we modularize the code? Do we just say, hey, we have 100 lines, 33 lines go into file 1, the next 33 ones in file 2, and the last ones in file 3? Or how do we modularize? The strategies you have in mind, yeah?
Related to what they handle.
Exactly, right? So you kind of relate functional relationships, right? So similar, yeah, so what would be examples for that in our assignment? Yep.
A file for structs.
Yes, exactly, right. So you separate structs from the rest, right? So yeah, you have a comment?
Well, I would say absolute minimum of modularity should at least be that you have one file for structs, one file for the main, and another file for the handlers.
Cool. Yeah. So I think for the assignment it's sensible. You can push it, of course, but I probably wouldn't need to because it's not. You wouldn't have that many structs, I believe, right, in the assignment. But I would not know. Sorry, there's another comment where. Sorry, please go for it, please.
So when you modularize your code, do you want to have a file, say, with all the handlers by itself, or do you want to split it up for what they do? So, for example, do you want all the handlers in one file, or do you want, for example, commits to be one file with the commit handler and some functions relating just to commit? So do you want to have the same type of functions in the same file?
That's what I think I would do. I think I would have the struct for that kind of thing at the top of the file, and then I would have whatever help functions I use in that handler, and then I would have the handler in one file, so I have everything gathered in one place. You don't have to jump around the entire place whenever you try to read how it works. You just have, oh, now I'm in the main file. Oh, there's one handler over here in this file, so I go to the file and then see, there's a struct. Okay, so we're going to be handling this data from this thing, and here's a URL to some API and some endpoint. Okay, so we're going to be getting this data from this endpoint, and just by looking at that, I already know kind of what's going on. And then I have all the help functions and everything in one place, so it's very, very easy to view.
Yeah, so you take the kind of like the main function of the task you want to complete in one file.
But that only kind of works when it's a small. It's a small piece of code. Like when you have a gigantic project, that like you might not want to have all the structs for one task, because there might be a lot of structs for one task.
But it's also about reusability, right? If the point is that the delineation is basically when a struct is used by something else but the handler, you probably need to think about externalizing it to a separate file or struct, right? But it's really dedicated for this handler, as in our case here, largely. Yes. Then yeah, of course, please.
Yeah. So in general, you sort of follow the same heuristic as for writing code, which means minimizing the modifications you need to take when you do changes, right? So you have to think, okay, if I need to add functionality, how many different files do I need to touch? If you organize it in the first way, you have to touch all the files, right? Because you kind of have everything spread around. But if you organize it in the second way, you only need to add one extra file or change stuff in one file. So that's better. So the less things you need to touch to do changes or to introduce new functionality or to refactor your code, the better your logical organization of the code is. So there is no kind of gold answer, right? No. Sometimes you start with a small project, and it makes sense to have certain organization of your code, and as the project grows, you say, actually now I have to touch too many things, I need to reorganize it, I need to group it differently. So then I don't need to touch so many things every time I'm doing small modifications or adding new type for the handler or whatever you're doing, right? So it's kind of a living thing. It's like there is no one single answer which says, yeah, always do this.
Actually, probably it's a living thing in a sense that you need to be flexible enough to modify, refactor your code at any time as soon as complexity increases, right?
I think so, yeah. I think that refactoring and reorganizing your code, remodularizing it is part of developing, right? So sometimes you just start with one file, which is fine. As the project grows, you need to split it into multiple files, and then you may need to reorganize it. So it's fine. That's the process. Yeah.
Cool. Good.
It should be logical. So someone who is reviewing your code and says, okay, now I'm reading about this commit logic, it should be clear where to find what is needed to understand what's going on. If that person needs to check 20 files, that's probably not a good design. If that person needs to check 1 or 2 files, it's probably better because everything is kind of logically there, right? So yeah.
Cool. I think the rest is largely, recollection of the previous points. I didn't find anything that's substantially new. So our documentation is again pointed out best practices, whatever that will be. What are best practices in our context? Both as professional developers, but also as specifically cloud participants in the class. What would be best practices you could think about? If you were to start a new project, what should you have in the back of your mind, independent of the project description?
I was thinking limiting the scope of variables.
Okay. Yep. Why do you do this?
So it can't be reached from other places where it's not used, so it doesn't take unnecessary space too.
Cool. Very good. Yeah, that's a good point. What other points are there? Also more like general. Yeah. Okay, continue. Anyone else? Other comments? What should you generally consider when doing development projects that go over more than a day, hopefully anyway?
Your workflow.
Workflow. Oh, interesting. Elaborate. Yeah.
Also, how you develop, what tools do you use?
Yeah.
What methods do you use? For example, if you use Git,
right?
What kind of workflow are you going to use? Are you going to use a GitHub workflow where you just branch out a master, or how do you want to do that? Are you going to go from issues?
Yeah.
That kind of workflow.
Very nice.
What you're already using.
Very nice. So yeah. So I mean that's kind of the real professional perspective, especially if you think about you're running a project that's reasonably complex, coming back to complexity, and you may also have disruption in between, right? So or you suddenly discover a problem that you want to address later because the code is too complex and you're working on another feature right now. You can quickly create an issue and so on. So you will not lose that piece of information, of course. But in a more immediate sense, you also want to look at your versioning strategy, right? Keeping track of your code and so on, but also how you do development, right? Do you do it, as you mentioned, in branches, or are there other means by which you want to automate part of the testing or deployment or assessment of the code? But at least, I guess, versioning is kind of sensible, right? So for your own sanity, because at least you can always return to a working state of the code. And it's easier to share. So if you want someone else to look at your code, well, share the repository, right? So else you're sending around zip files. Good luck with that. So that's a very practical concern. What other concerns should we bear in mind? You mentioned tooling implicitly. Was there coverage on tooling in Go firms? Vet?
No. Do you know what Go Vet is?
What?
No, we have not touched on Go.
Good, then we do Go
We
Vet.
haven't
Next
done
session.
the tooling yet, but we should, yeah.
We should. So, okay. So
that also relates to one of the earlier questions about static analysis, because if you do proper Go tooling, they will do some of the analysis for you.
Yeah, that's right. Cool. All right. So let's see. Let's leave it this. So now review, right? How many of you have looked at a review form already? Okay. See, I can find the obvious one who did the N,000 reviews. So no, it's too much noise already at this stage. So I can't identify the individual anymore, which is good. So so fundamentally, what you see if you open up your the submission system again, what you will see is now you see the same assignment, but it allows you to click into the assignment and do a peer review. And we expect you so basically you go into look at the assignment, see details, and I think you can say create peer review or something like this right now. Don't know on the top of my head. See if I can log in. So I'm not part of the course as a student, so I can't give you a visual on that one. But in any case, you should see a review form. What it does, it randomly picks someone else's contribution, and you will be presented their URLs, of course, the Git repository, but also Heroku URL. And some comments, forceful comments, as we identified. Comments is a mandatory field in the submission system, so not all the comments may make sense, but in some cases, people will probably have put some information there, something along the lines of, sometimes my Heroku deployment doesn't quite work quite well, and so on. So it's also important to recognize that people realize their own problems. It's not just it's helpful to be straight up with it. I know something's not quite working as it should, but at least it's kind of working as opposed to I think it's working completely, and you realize in your review, hang on, it's not happening. So the comments are generally very helpful. So recognize them if people provide them. So I think that's just fair. But so generally people are concerned, of course, how do we do a code review now, since we haven't necessarily experienced. But that's the idea here. This whole form, this is basically the edit view here, guides you through the process of actually assessing the code. And the questions are relatively straightforward. In most cases, it's radio buttons that you need to click and select, and you can provide comments regarding the actual coding contribution. You can see the review form.
Yeah, I have it on my computer.
I see. But it's local, right?
Yeah.
Yes.
Would like to log in on the web browser, so you can show it off.
Yeah, that's would be an option if you could probably do that. Hang on. Let me just hide my screen a bit. Yo, please.
This is the one we set up, right?
Yeah.
Okay, nice.
That's right. So then you see the student's perspective. That's a bit helpful, more helpful.
Yes.
Yes, beautiful. Yeah, break. Thank you.
Good idea.
Thanks for a reminder. Break. 9:15. 6 minutes will work. Yes. No. 9:15. Okay. Cool.